Hello everyone. Today we'll be doing the chapter Atomic Structure. We all know that matter is made up of very tiny indivisible particles called atoms. So today we'll be doing the structure of an atom. Before starting off with the structure of an atom, we will discuss about Dalton's atomic theory. This theory was given by a famous English scientist known as John Dalton. According to him, all elements are made up of very tiny individual particles called atoms. That means all elements are made up of atoms. Atoms can neither be created nor destroyed. We know matter can neither be created nor destroyed. So, similarly, since matter is made up of atoms, atoms also can neither be created nor destroyed. All atoms of an element are identical, but atoms of an element differ from the atoms of other elements. Now, this means that all elements, like suppose oxygen is made up of similar types of atoms, hydrogen is made up of similar types of atoms, carbon is made up of similar types of atoms, but the atoms of oxygen is different from the atoms of hydrogen. The atoms of hydrogen is different from the atoms of carbon. So in an element the atoms are similar, but they are different from the atoms of another element. Then the next theory that he presented was atoms of different elements combine in fixed whole number ratios to form compounds. Now, for example, water is made up of hydrogen and oxygen, H2O, two atoms of hydrogen and one atom of oxygen. So whenever a compound is formed, the elements they combine in simple whole number ratios, like carbon dioxide, CO2, one atom of carbon and two atoms of oxygen. And the last one, in a chemical reaction, the atoms do not change but rearrange themselves to form new compounds, like we've already done in number 2. Atoms can neither be created nor destroyed. So, what happens? Like, suppose I'm giving you the example of water again because it's the easiest example. H2 plus O2 gives out H2O. Hydrogen plus oxygen gives water. Now, when we started off, there were two atoms of hydrogen, H2, two atoms of oxygen, O2. But how much, what was formed? H2O, two atoms of hydrogen and one atom of oxygen. So what happens is the atoms, they do not change into a new form, but they just rearrange themselves so that a new compound is formed. And we've already done balancing of equations. So why do we balance equations? So that the number of reactants is equal to the number of products, because matter can neither be created nor destroyed. Let's discuss the structure of an atom. An atom consists of a centrally located nucleus which contains the protons and the neutrons, which is surrounded by orbits in which you find electrons. Okay, so in the center you have a nucleus which contains the protons and the neutrons, and we find electrons revolving around the nucleus in fixed orbits. J.J. Thomson discovered electrons. J.J. Thomson discovered electrons. It was Ernest Rutherford who first studied about nucleus, so he discovered the nucleus. E. Goldstein, he discovered the protons. E. Goldstein discovered the protons. And James Chadwick discovered neutrons. James Chadwick discovered neutrons. Many people compare the structure of an atom with the structure of the solar system. It is more or less the same. We have in the solar system, we have the sun in the center, and uh, the planets revolve around the sun in fixed orbits. Similarly, in an atom also we have a centrally located nucleus, and around it we have electrons moving around, revolving around the nucleus in fixed orbits. But there is a slight difference. In the solar system, the orbits do not overlap each other. The orbits do not overlap each other. Whereas if you see in an atom, the picture that I'm showing, the orbits are overlapping each other. So there's a slight difference between the structure of the solar system and the structure of an atom. In the structure of the solar system, the orbits do not overlap each other, whereas in the structure of an atom, the orbits overlap each other. Now let's discuss about the properties of protons, neutrons and electrons. Protons are the positively charged particles of an atom. The mass of a proton is approximately equal to 1 atomic mass unit. And as I already told you, it is present inside the nucleus of an atom. Neutron does not have any charge. Even its mass is approximately equal to 1 atomic mass unit, and it is present in the nucleus of an atom. Electrons are negatively charged particles and they are present outside the nucleus, revolving around the nucleus in fixed orbits. Their mass is so less that it is considered to be negligible. It's very easy to remember the charges: P for proton, P for positive, N for neutron, N for neutral, that means without any charge. And of course, the last one is electron, so it will be negatively charged. In an atom, the number of protons is always equal to the number of electrons. Protons are positively charged and electrons are negatively charged. Like suppose if there are 5 protons, then there will be 5 electrons. So 5 positive charges, 5 negative charges. So because of this, the atom becomes neutral. The number of positive charges and the number of negative charges is equal. So this makes the atom electrically neutral. So number of protons is always equal to the number of electrons. Now we will discuss about the mass number and atomic number. The atomic number is equal to the number of protons present in the nucleus of an atom. Atomic number is designated by the symbol Z. The mass number is equal to the number of protons plus the number of neutrons in the nucleus of the atom. The mass number is designated by the symbol capital A. Now, if you see the figure that is showing on the screen, you will see that I've written capital X, then I've written A as the superscript and Z as the subscript. Here X stands for the symbol of an element, A stands for the mass number, that is the number of protons plus the number of neutrons, and Z stands for atomic number, that is the number of protons. So using this formula, we can easily calculate the mass number and atomic number of an element. Now see this example. I have written Na 23, 11, 23 as the superscript and 11 as the subscript. So I've already explained. Na stands for sodium. The superscript stands for mass number, that is A. So sodium has mass number 23 and atomic number, that is Z, is 11. So mass number is written as superscript, that is on top, and atomic number is written as subscript, that is below the element. Now we have already discussed that atomic number equals the number of protons, and the number of protons is always equal to the number of electrons in an atom. Mass number is equal to the number of protons plus the number of neutrons. So using this formula, we can calculate the number of protons, neutrons, and electrons in an element. Now see this example. I have given you again sodium 23 and 11, and I have asked you all to calculate the atomic number, the mass number, number of protons, electrons and neutrons. So based on the formula X is Z, atomic number is the subscript that is on the lower side, that is 11. Mass number is the superscript, so that is 23. We know that number of protons equals to the atomic number, so the number of protons is also 11. We also know that the number of protons is equal to the number of electrons. So if the atom has 11 protons, so obviously it will have 11 electrons. So if you see the atomic number, the number of protons and the number of electrons will be the same. Now we come to the number of neutrons. We already know that mass number equals to number of protons plus number of neutrons. So if we minus mass number and the number of protons, we will get the number of neutrons, that is equal to 12. So I hope you all understood what was done. So using this method, you can easily calculate the atomic number, mass number, number of protons, electrons and neutrons of an atom. Thank you. Bye-bye.